In this video, I'm going to go through the analyses associated with testing the hypothesis that two variances are equal, but it's in the context of actually having a theoretically driven hypothesis about the variances being different or being equal depending on the hypothesis. So in this case, the study is about level of expertise and the capacity to throw a pitch at a particular speed when the pitch is supposed to be a change-up. And so in this case here, I've got my dependent variable here, pitch speed, all in a row, and we got 90 pitchers that threw a pitch. And we also have a grouping variable, which is labeled 1 for major leaguer and 2 minor leaguer. And I'll note that a minor leaguer, for those who don't know, they're still professional baseball players. They're just not quite at the high enough level to actually be a major leaguer. And so let's look at the actual variances first. Go into Analyze, Descriptive, Explore, and we're going to put pitch speed in the dependent list and group in the factor list. And we'll look at the histograms, stem and leaf, and statistics. We'll look for outliers at the same time and click OK. And this will give us a whole host of descriptive statistics, including the mean. So they were aiming to throw a pitch at 78 miles an hour, and the major leaguers threw at 78.095. Importantly, though, the variance was estimated at 0.309, so a very little variance. And minor leaguers threw the pitch on average 78.21 miles an hour, very similar to the major leaguers, but the variance in the throws was 1.763. And the hypothesis is that major leaguers are more consistent with their pitch than minor leaguers. So is this 0.309 statistically significantly different from this 1.763? And we can test that hypothesis by actually going into the independent sample t-test utility. It's not the only way to do it. I'll show in another video how to do a more robust way of testing the homogeneity of variance assumption. Put pitch speed into test variables and group into grouping variable. And we need to define the groups. And from memory, they're 1 and 2. So it was major leaguers 1 and minor leaguers 2 from memory. Click OK. Yep, it worked. And we can see that the means are re-reported. The sample size is 45, so there were 45 major leaguers and 45 minor leaguers who threw that pitch. And here are the standard deviations. So the homogeneity of variance test that is by Levene's is technically on the variances. It's not the standard deviation technically. So here is the actual test. And we can see that the Levene's test had a f-value of 16.536 and the p-value is 0.000. Now you can disregard this equal variance assumed because that is only for the t-test. It has nothing to do with this portion of the table. So I have rejected the null hypothesis that the variances are the same. So this variance is very unlikely to be coming from the same population as this variance, and this result suggests that major leaguers as a group throw a 78 mile an hour changeup with greater consistency than minor leaguers do. And that is how you could test the difference between variances when you're interested in the hypothesis from a theoretical perspective.